Good morning. My name is Miles Choquette, and today I will be presenting my project titled Predicting House Prices. This project focuses on using machine learning to analyze property attributes and predict house prices, offering valuable insights for stakeholders like buyers, sellers, and investors. The goal of this product is to develop a model that accurately predicts house prices. Such predictions can help various stakeholders make informed decisions in the real estate market. For instance, buyers can assess fair prices and sellers can strategize pricing to maximize value. For this project, I used the Kaggle housing dataset, which includes 500 entries and 13 features. Key features include property area, the number of bedrooms, and price. The target variable for our model is property price. During the exploratory data analysis, I found that larger property areas generally correlate with higher prices. I also identified several outliers, such as properties with unusually high prices. Fortunately, there were no missing values in the dataset. Next, I focused on data pre-processing. Categorical variables like yes or no were converted into numerical variables such as 1 and 0 to ensure consistency. I applied feature scaling and treated extreme outliers, particularly in the price per square foot. I created a new feature called price per square foot by dividing the price by the area using recursive feature elimination. I selected key features like area, air conditioning, and parking to improve the model's predictive power. Three models were tested: linear regression, decision tree, and k-means clustering. For regression tasks, I evaluated the models using R-squared and RMSE. For clustering, I used the silhouette score. Linear regression performed the best, achieving an R-square of 0.88. Moving on to the linear regression model. This model achieved the best performance with an R-squared of 0.88 and an RMSE of approximately $767,007. These results indicate that the model explains 88% of the variance in housing prices and has a reasonable prediction error. The script for linear regression was implemented using Python's scikit-learn library. The process involved splitting the dataset into training and testing sets, fitting the model to the training data, evaluating it using metrics like R-squared and RMSE. To improve model performance, I focused on feature selection, ensuring that only the most relevant attributes like area and parking were included. This model demonstrates the potential of linear regression in predicting house prices when relationships between variables are mostly linear. K-means clustering was used to group properties based on their similarities. The clusters revealed patterns among properties, such as those with high area and price forming a distinct group. The silhouette score for this clustering was 0.596, indicating moderately well-defined clusters. Cluster 2 in particular highlighted properties that could target luxury buyers. The script for this analysis used the k-means module from the scikit-learn library. Key steps included normalizing the data to improve clustering performance, selecting the optimal number of clusters, and using the elbow method, visualizing the clusters to interpret the results. The analysis provides actionable insights by segmenting the market and helping stakeholders focus on specific property types. Linear regression had the highest R-squared at 0.88, with an RMSE of approximately 767,000. The decision tree, after tuning its maximum depth to 5, achieved an R-square of 0.85 k-means clustering. K-means clustering had a silhouette score of 0.596, revealing property segments based on price and area. Insights from the models include identifying properties in Cluster 2 as suitable for luxury buyers due to their high area and price. Features like air conditioning and parking were also found to significantly impact prices. This information can help sellers renovate strategically and buyers negotiate better deals. Despite the promising results, there were challenges. The dataset had potential biases, and it lacked regional diversity. Linear regression struggled with nonlinear relationships, and the decision tree model was prone to overfitting. In conclusion, linear regression was the most effective model for predicting house prices. Clustering revealed distinct property segments. Moving forward, I plan to incorporate features like location and test the models on more diverse data sets to improve accuracy.